So I'm going to continue on. I just showed you how to use xlsread. And I wanted to just show you how to use this in the form of an example, the way I try to run a lot of the things in this class. And so what I have here is I have raw data. It's all plotted here. I'm going to recreate this plot for you. But it's all, there's data that has been taken for elongation and force. So effectively you apply some force to a sample, some material sample, and you get an elongation. And so usually you're looking for like trends, right? So you might be looking for a slope or something, some way to represent the elongation based on force, and the same for this kind of more scattered area here, which gets more linear, it looks like. And so I have 4 tests. Let me show you the data. It is in Excel. And so the easiest way for me to get that is here. It's in Excel. It's in this file called Excel to MATLAB. It'll be online on Pilot for you to use. So there are 4 samples here. And so what I'm trying to do is I'm trying to use this, import it into MATLAB, and use it in specific ways. And so I've got 4 samples, force elongation data. My first goal is going to be, if I pull up the PowerPoint again, is to just plot all 4 of the raw data samples. And then I want to create this plot on the right. I want to use a spline fit, which I showed you a few weeks ago, towards the end of the week, just very briefly. All right, here's how you do a spline fit using MATLAB. It's very straightforward. I'm going to do a spline fit, and then I want to do a polynomial fit below it. And this is going to be the average data. So there are 4 samples, so I'm going to average the force and elongation for all 4 samples, and then I'm going to use that as like my kind of quote-unquote real data, right, to try to use as a fit. And then I want to use the spline fit, and then I want to use a polynomial fit. But what I want to do is I want to request from the user a pop-up dialog box of what order fit is required. So basically, I want a box to pop up. You say, all right, what order fit do you want? So you can do any number you want, right? And then it'll go do the fit for you, and then it'll plot it. And then I want to write the spline data out to a text file. And so let me pull up MATLAB. So I'm going to open a new script. I'm going to pull this up to the side for now. So remember, I want to use that data somehow, and so maybe it would be better if I pull this up to the side. So I want to import it, and I want to import each sample. So first I need to clear everything like normal. And then I'm going to import it. So if you remember, you can do num text raw. I'm just going to do num is equal to xlsread of Excel to MATLAB.xlsx. That's my file name there. So that's important. You have to make sure you get the correct file name. That way you can actually pull in the data and use it. So let's see what this ends up looking like, because I have these numbers down here that I used in my calculations, and so I'm going to need to manipulate that data a little bit once it's done. So I'm gonna export it to I'm gonna allow it to go to the command window, and I want to see what happens. Yeah, untitled's fine. All right, and so if you notice, it brought all my data in. But then it also included all these nans, because it included all the data, all the lines basically right here between where the numbers were in the data. And if you remember from the last example, that includes any nans. Any empty spaces in the Excel worksheet is basically considered not a number. And so I really only want this data here. And so what I can do is I can just start importing it. I can start using that I just created. So I'm going to do force 1, so it's going to be the force for sample 1 is going to be equal to num of the rows are going to be from row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm going to go rows 1 to 16, and then I want only the first column, right? So that is going to be force 1. Then the elongation 1. So 1 is going to be, and I'm going to start this convention, 1 is going to be for sample 1. It's going to be the same as the previous one, so 1 to 16, but instead of row 1, it's row 2, right? So I'm using this row here. And using the import this way, I'm gonna suppress this. I don't need it anymore in the command window. Importing it this way, remember, only imports the numbers. I could have done that num text raw if I wanted these the text of these headers. I don't. It doesn't matter to me. All right, so now I've done that, and now I just am going to copy and paste this. There are 4 samples, so there's 4 here. So the second one, force 2 and along 2 are going to be in rows 3, or columns 3 and 4. So 3, 4. And then for force 3 and elongation 3 for sample 3, force is going to be in row 5, and then elongation is going to be in row 6. So I just kind of keep incrementing these up by 1 every time. And then for the 4th sample, it's going to be rows 7 and 8. 7 and 8. All right, so that's me importing all the data. So I'm going to start commenting this. So import all data. All right, so I've got all of my data now imported. So that was kind of step 1. Let's go back to my presentation and see what it wants. So I want to create a plot of all of these data points. That's actually pretty easy. So I'm going to say plot raw. I'll try and keep the convention right here. Okay, so I can actually use all of these in one plotting function, but I'm not going to. This is going to be force. So now I need to pay attention real quick. Before I even type anything, I want to make sure I do everything correct. And so let me full screen this. And so force is on the y-axis, elongation is in the x-axis. And so I need to be careful with that. I almost did it wrong. I need to make sure that elongation is x always from here to the rest of the example, and then force is going to be on the y-axis. And so when I'm doing my spline fit and polynomial fit, I need to remember that force is y, elongation is x. And so elong 1, force 1. I'm going to match it, so I want blue circles for every point of data. And so now I'm going to create a figure. I probably should have done this first, but it's going to be equal to figure, and then fig1 dot color is white. So remember, I can do all these in one line because kind of the same way I always do this first line here is when a semicolon basically means that you're executing these as separate lines, and so you can keep them in the same line of code. All right, so there's the first plot, and now I need to hold on, and now I'm just going to I know I do this a lot, copy and paste, because there's no need for me to type out all of that when I can just change my variable. So this is going to plot sample 2. This is going to plot sample 3. And this is going to plot sample 4. Okay, so all of these line up. You can kind of highlight them if you want. You can kind of run your cursor over them, highlight it, and you can see that all of these variables are used in the right place. But that's not entirely necessary. So I have that. So let's run it, see how it worked. Wonderful. So now I need to create my X labels and Y label. And the nice thing about these is I can actually reuse these. So I'm going to reuse these for both of my plots later too. Elongation in inches. My Y label is going to be force in pounds. And then I think I'm going to just make my title be raw data. And that should match pretty closely to what that other plot was. So let's see how it looks. Great. So force, elongation, raw data. All right, that looks good. All right, so let's go to the next step. So now I need to create the subplot for the spline fit. And so first I'm going to need to average. I'm just going to call these force and elongation. So I'll probably do elong again. So these are going to be the means of it. So what I'm going to do is I'm actually going to, instead of using the mean function, I did it a little different way. I'm just going to average those data sets I saved as different variables. And then I'm going to create a subplot. And I want to, probably even before the subplot, is I want to create this spline function, right? That's going to connect all of these points. So I need to create a spline, and then I need to create a polynomial fit. Let's do the spline first. And so I'm gonna comment here average data. And so my force average is going to be equal to force 1 plus, it's going to be the force 1 plus force 2 plus force 3 plus force 4 divided by 4. That's how you do an average, right? And then my elong average. And this is what I'm going to use for my spline fit, is this underscore average. That's telling me, when I go to look at it later, that's the variable that corresponds with the average. So it's going to be the same thing, but elong 1, elong 2, elong 3. It must be so fun to watch me type all of this. Over 4. Probably about as fun as actually typing it, so feel too bad, I guess. So you've got this data here. So now I need to create my spline data. And so what I want to do, so remember, my x-axis is elongation, my y-axis is force. So I need a plotting elongation axis. So remember, I need a I need something to use to plug into the spline function and then the polyfit function later on. I need the whole range to plot during. And so I'm going to create this elong plot. This is going to be my x-axis plot for the plot. It's going to be equal to, and I'm going to use the linspace function as I've used before. And I'm going to start at elong average of 1. So I'm going to start at the beginning of the elongation, and then I'm going to do elong average of end, and then I'm going to fit 1,000 points in between. It's probably too many, but that's fine. So what that effectively does, if I pull this up, is that's going to create a plotting x-axis basically that starts at the first point, ends at the last point, and fits 1,000 points in between. And as I've stated before, what that will do is that will kind of give me enough points to show this entire curve, whatever fit I'm using. And so now I need to apply the spline fit. That's actually pretty straightforward. So I'll say force plot. That's YY on the lecture notes, but I'm trying to be a little bit clearer because these are going to be what I use for my plot. It's going to equal to spline, and let's remind ourselves what the inputs are. Inputs are x, y data that you're going to fit the spline to, and then where you want to evaluate x. So it's going to be, remember, elong is the x-axis, force is the y-axis, and then I'm going to use this new vector I just created and evaluate basically a spline along the entire elongation range with 1,000 points. And that's all it takes to do the spline fit. So now I can go and plot. And so I'll do my first subplot. Remember, it's going to be a matrix of plots. If I show you, it'll be evident. So it's a matrix of plots, two rows, 1 column, and the first plot is where I'm going to put the spline. And then I'm going to plot. So I can create my whole figure before the subplot. So I'll do fig2 is equal to figure, and then I want it to be a white background. And now I will plot. I remember on that plot here, I've got the blue circles of the average data and then the red curve of the spline fit. So I want to do that. So I'm going to plot the average data first, just the data points. So it's going to be elong average force average. So this is going to be my actual data, and I'm going to have it have blue circles. So it's just going to be the markers. Then hold the plot. And I probably at the end of this one should have held off, but I'm going to hold the plot, and now I'm going to plot instead of the average. I want to plot these plotting functions these plotting values I just created. So force plot and elong plot. And maybe instead of the plot, I'm going to do spline and spline, just to make it even clearer. Because I'm going to actually be plotting this and the polyfit value, right? And so I'll do hold off. And like I said before, I'm going to copy and paste these X label, Y label, and title because they actually are about the same. The title is just going to be spline fit of averaged data. Okay, let's see what this looks like. Oh, instead of blue circles, I need to use a red line, and then we'll see what it looks like. Not T. Oh, I have an error. Let's see what it is. Oh, I deleted elong plot, so I need to. So what this is saying is that undefined function or variable elong plot. That means that I have not defined elong plot anywhere. That's because if you remember, I changed the name of it. I must have missed one place for it. Great, and so now you can see I'm over halfway there. I've got my raw data plot, and now I have my spline fit plot. And so the next step is I'm going to keep this plot actually at the bottom here. My next step is I want to request from the user a pop-up dialog box asking for the fit, and then use that dialog box to create a polynomial fit of that order for the average data. And so next what I'm going to do is I want to apply polyfit, right? So now I get an input dialog box, and so I'm going to do fit string. It's going to be equal to input DLG, and so now you need to give the prompt and say enter what order of fit, and I'm just going to keep it that simple. And remember, this fit string ends up being a cell array of whatever you typed into the box, what order of fit. So that's in this case going to be whatever order of the fit it is. So that is a cell array, and inside that cell array it gets stored a string. I showed you that in the last couple of videos. So or 2 videos ago, I think. And so in order to pull that out, I need to say, all right, so my actual fit is going to be equal to fit string of 1, because remember I could pull out the cell array, and then I need to turn that string to a number. So that function is string to num. To repeat, this gets stored in a cell array, which I use the curly brackets to pull out, and I know there's only one value in it. And then I know that that output is still a string. So if I put the order fit of 1, which is going to be how I show you this example, I want to turn that to the actual number 1 to be used in the polyfit function. All right, so I've got that. Now I need to find my coefficients. That's equal to polyfit. So remember, you use polyfit. We learned that in the last kind of topic. You use the polyfit function. You give the x data, which is the elongation average, the y data, which is force average, and then you give it the order of fit you want to use, and that's what I just asked for. So that's this fit here. And so all that this does is it finds the coefficients of the polynomial of the fit. So now I need to actually come up with the numbers. And so now I need to use the polyval function. And so I'm going to use, so it's going to be force fit is going to be equal to polyval of, I need to give the coefficients, which is p. I just calculated those. And then I need to give the values to calculated at. And I'm actually going to use this elongation spline, because this is general, right? This gives me the whole range of the average vector. So that I can use for both these functions. So I don't have to create a second variable. Okay, and now I've created this fit. And in just these 4 lines, I've asked the user what fit to use, converted that, calculated the coefficients of the polynomial, and used the coefficients. So in 4 lines, you basically have answered a pretty complicated question, right? It's this whole part right here, and then everything but plotting, number 3. So now I need to plot. So let me run down here, and I'll space this out a little bit. And so I'm going to copy and paste this, and the reason I'm copying and pasting it is because it's basically the same, right? All I did before is I plotted the spline fit. Now I just need to plot the polynomial fit. And so I need to plot the second, put it on the second subplot, and I'm plotting the original data. So remember, if I pull that up again, I'm plotting the original data, which are those circles. It's the same in both plots. And then I'm going to plot the polynomial fit. And so elongation spline is still my x value I used here, but now I need to use force fit. instead of for spline, and it's going to have a red curve. It's the same plot, just with my polynomial fit of whatever order. And so now my x label and y label are still the same. It's the same functions, right? It's the same. X label is still elongation on the x-axis, force on the y-axis. And now I have this title. I want to change this. And I'm going to call this polynomial fit of order. And now I want to include whatever order that I input, that I ask the user for, right? That I use the input dialog to ask the user and store it in a variable. So now I've showed you this before, is I can build a string, right? So inside of these brackets, remember, a string is basically just a vector of letters. And so I can add some letters. I can add a string that is that number that I just calculated for fit, right? So I have this fit number, and so I can use num to string, which is the opposite of string to num, which I used here. It'll turn that fit number into a string. And so what it'll do, it'll polynomial fit of order, and if I put 1, if I want my first order fit, it'll be polynomial fit of order 1. Okay, and so that plot should be done. Let's check it. So I'm going to do a fourth order fit right now because I want to match the plots that were there before. So now I have my spline fit, and now I have my polynomial fit of order 4. And that looks about right. That's exactly the same as all this data here. So I've recreated my 2 plots. And the nice thing is that this plot will change, and this number right here will change depending on what I put into my dialog box that pops up. So I'm going to put a 1 in here. And there, so now it's a line. My spline got a little funky, but it's okay. Okay, and so I've recreated those plots. So the last thing I want to do is I need to write the spline data out to a text file. So that's going to be using the fprintf function. Write data to text file. Remember, you use the fprintf function for that. And so first I'm going to test this fprintf function. I'm going to put it in the command window first. And so it didn't say to use the headers, so I'm not going to use the headers. So I'm just going to do fprintf of. So I'm just going to put the numbers. I'm going to say 6 point with the percent sign tells you all right, you're going to put something in this. You're going to put something in this, and it's going to be 6 spaces wide. Allow 3 decimals after the period. And I'm going to separate them by a comma and a space. And the other number is going to be basically the same, right? And so I'm going to output the elongation and the force. And so now I need to give the actual values. And remember, I'm outputting the spline values. And so in order to do this, if you remember from 2 videos ago, is you have to include them as row data. So I need to include, if my first line is going to be force, let's say it's force, I need to make sure that they stay as rows, right? So they have to stay as rows. I'm going to say that one more time, rows. And so you have this semicolon that separates rows in an array, right? And so what this does is the first row gets input basically as this first value. So it's going to parse through every time and go force spline, elongation, and put them in either of these. So force spline goes here, elongation there, and then I need to put a new line, right? And then it'll go to the next line. Then it'll be force spline, elongation, new line, force spline, elongation, all the way down, and it'll build this table. And let's test it. I'm going to do order 4. There, my spline looks better there. For some reason, the last time it got a little wonky. But everything looks fine. And if I look at my command window, look, it output all that data. And the nice thing about commas is a comma separated, you can import into functions very easily. So if you use this comma here, you can comma separate it, import it into Excel, for example, and plot it. And so now I just need to actually write it to a file. And so I'm going to fopen. And I'm actually going to put it in here, text data. And I could do .csv because I'm comma separating it. Because CSV just means comma separated. Or I could do .txt. Either way works. And so remember, I have to set this equal to a file. So I'm going to say f1 is equal to this. And then in order to use that in fprintf, so I've opened it. I have to give it the right permission. And in order to use it in fprintf, I need to pass this variable as the first input into my fprintf function. So now I have fprintf in f1 write basically everything that's given by these two statements. And then I need to fclose f1. Right, and so if I'm just going to delete this. It shouldn't matter, but I'm going to delete that. Let's run it. I'm going to give it the order 4. Recreated my plots. They seem like they look different about every time, but I'm going to ignore that because my code's definitely right. And so now I have this text data right here. And if I open it, the easiest way to open it is actually in Excel. And you could use this data. So I could go and I have all this data, and I could go in and just show you really quickly how I could maybe plot this in Excel. I could go insert, plot, a plot here, and then you can right-click that plot, hit select data, and this isn't a test. You don't need to know how to use Excel for this class. It's just a useful skill to know how to use at least basics in Excel. I'm just going to select all of this. Not necessarily the most elegant way of doing it, but it works. So it's from 1 to 1,000, and then I can just copy and paste. That's going to be my x-axis. I might have plotted these backwards. Let's see how it looks. All right, so it's inverted. So I used the wrong data, because if I were to go back to MATLAB, I put force in the first column, elongation in the second column, and I want to plot elongation versus force. So I'm going to switch these around. So all I'm doing is I'm changing A to B. So it's going to say that this second column is the x value, and the first column is going to be the y value. There, and so now I've got all the spline data right here. This is going to be force versus elongation. And so now I've gone in and I've exported it, and now I've gone in, exported it as a CSV file, and then you can just open it in Excel and use it. Or I could open it in another MATLAB function and very easily manipulate it, either through an Excel file or through a CSV file. Either way works. And so I've shown you an example of how all of these things can kind of be combined. And so what I want you to do, and so now we have an in-class problem, is this data is from a previous Excel file. And what I want you to do is I want you to find out which curve is better, a power fit or a second order fit. So this is going to be a review, right? So how do you do a power fit? How do you do a second order fit? Wonderful. And then I want you to plot the better fit of the two over top the data. So you need to use R² for both these fits, calculate it, and then take that fit and plot it over top the data. And then I want you to use fprintf to output the better fit to the command window alongside the corresponding R² value. And there you go. That's how you use input-output. And so the next topic is going to take a little bit of a curve, but for now, that will be it.